Did you get that? Miss Oyami, okay, all good. That's good. So others will just join us as we move along. So now, today I've prepared a lesson on projectile motion. Okay, so I'm going to run this trial lesson for exactly 40 minutes because you know, we started late. My plan was that I wanted to start at exactly 5 o'clock so that I can stop at 6 o'clock. But since, well, I'm behind by a few minutes, it's not really a problem since it's a trial lesson. So should you wish to, continue taking lessons with us, then, I will make sure that I repeat this lesson. Okay, so let's start. If I may ask, what do you understand by the word projectile motion? What is a projectile? What is a projectile? Anyone? A projectile? So you know anything that you throw, right? Anything that you give, if you take an object and give it an initial velocity, basically if you throw it in the air, with an initial velocity of v, that's a projectile, right? So whenever you give an object an initial velocity, then it becomes a projectile. So let's go back to grade 10. There's a couple of terms that you've learned in grade 10, so and in grade 11 as well. So I would like us to go back to grade 10 and grade 11 and just revisit those terms because they are really important for the section that we are about to discuss. Now the first one is the distance. What is the distance? And then what is the displacement? So I want us to discuss the two. So in projectile motion, we will be talking about the distance, we will be talking about the displacement. So before we can dive into the lesson, we really need to have an understanding of what it means when someone says this has a displacement of 2 meters or that has a displacement of 4 meters. So let's do this. Let's say that you have 2 points. You have point A and point B, right? And then you want to move from point A to point B. Now there are two ways in which, or there are multiple ways in which you can get to point B, right? You can either move in a straight line like this, or you can take a longer route, right? And then get to point B. Point A was your starting point, and then point B, it is your destination. Now, you've covered a distance of X meters when using the route highlighted in, let me highlight it in red instead. So let's say that this is the total distance that is covered. Okay, from A to B, you've covered a distance of, let's say, 20 meters when you follow the red path, right? But now, let's say that you move from A to B by just moving in a straight line. So you're getting from A to B in a straight line, right? There's a difference between the two paths, right? With the first path, the path in blue, you can see that you are connecting the 2 points in a straight line, right? Meaning that the blue line represents what? It represents the displacement. What is the displacement? The displacement, it is the shortest distance to your destination, right? That is your displacement. But the red path, since well, you are taking a longer route, then it becomes a distance. So I hope you understand the difference between the displacement and the distance now. Now this is the distance. That's how we define it in physics. This is the distance, and then this is the displacement. Okay, so your displacement is actually your shortest distance to your destination. All right, so there's also this term called speed. We have what we call speed. We also have what we call velocity. So the question is, what is the difference between the two? So you have your speed and you have your displacement. I mean speed and you have your velocity. Now what is speed? Speed, it is the distance that you cover over time, right? Over a time interval between the 2 points. So now let's say that you walk for 2 meters to the right and then you take 2 seconds to actually cover that distance. So what will be your speed? The magnitude of your speed will just be the distance divided by the time. So speed is what? Is the distance per unit time. And speed, it's a scalar quantity, because when we express it, we do not indicate the direction. Okay, and then we have what we call the velocity. What is the velocity? The velocity, it is the rate of change in your displacement, right? The rate at which your displacement is changing, that is your velocity. So your velocity is basically just your displacement over time. Displacement over time. It is the rate of change in your displacement. Okay, so now let's move on. Your velocity is a vector quantity, right? It's a vector quantity. When you express your velocity, you have to indicate both the magnitude and the direction. So this is a vector. And then your speed is a scalar quantity, because we only concerned in the magnitude part. So when you define the speed of an object, you only indicate the magnitude, and no direction is associated with the speed, okay, because it is a scalar quantity. Now let's talk about acceleration. We have what we call acceleration. So the question is, what is acceleration? Acceleration, it is the rate of change in your velocity. Now, it is the measure of the rate of change in the velocity. So I'm going to spend some time talking about this one because it is really, really important. So your acceleration, it is the measure of the rate of change in the velocity. Right? So basically, your acceleration, which is a vector quantity, it is a vector quantity, and it is defined as the rate of change in velocity. So it's given by change in v over change in t. That is your acceleration. And remember, the acceleration is a vector quantity, right? Quantity. So now, how can you measure the acceleration? You can measure the acceleration of an object if you have the initial and the final velocity and the time interval between the changes that happen in between. Okay, so now the question is, how does acceleration occur? How does acceleration occur? Now, acceleration can occur in two ways. Acceleration can either occur by the change in the magnitude of the velocity vector, or it can change by the change in the direction. Okay, acceleration occurs in two ways. Acceleration occurs in two ways. So first, it occurs by change in the magnitude of the velocity vector. In the magnitude of the velocity vector. And then secondly, the acceleration can also occur by the change in the direction. Okay, so it occurs in two ways. It occurs by change in the magnitude of the velocity vector, or it can change by the change in direction. Okay, so now let's analyze the statement that I just put down. What do I mean when I say that acceleration can occur by the change in the magnitude of the velocity vector? Now, let's say that you have a car that is initially going to the right with an initial velocity of 5 meters per second, right? And then this is at point A. And then now, after some time t, you now have your car moving in the same direction, but now with a velocity of 10 meters per second, right? So do you see that as the object is moving between A and B, it is changing in velocity. So let's say that the time interval, the time it takes for this object to change in the velocity is 2 seconds, right? Let's say that the time interval it takes for this car to change in the magnitude of the velocity vector is actually 2 seconds. So we can then measure, not measure, but we can calculate the magnitude of the acceleration. So how would you do that? Acceleration is what? It's just change in velocity over change in time. And this is equal to your final velocity, which is 10, minus initial velocity, which is 5, divided by the time interval of 2. So basically you have 5 over 2, which is basically just 2.5 meters per second squared. So that is your acceleration. But now I mentioned that acceleration is a vector quantity, right? Acceleration is a vector quantity, meaning that when you write or when you express acceleration, or when you define it, you have to indicate both the magnitude and the direction, right? So you need those two, magnitude and the direction. Now, question is, how do we then determine the direction of the acceleration? So we use the change in the velocity in order to determine the direction of the acceleration. I'm going to show you how to determine the direction of the acceleration. So first, in order for you to determine the direction of the acceleration, you need something. You need the change in the velocity. So what you need to understand is that your change in velocity, which is just the difference between the final velocity and the initial velocity. So the change in the velocity and the acceleration, they are always pointed in the same direction. That's what you need to understand. Okay. So how do we then determine the direction of the acceleration? You need to understand that the acceleration vector and the change in the velocity vector, they always point in the same direction. Always point in the same direction. Okay. They always point in the same direction, but it does not necessarily mean that they have the same magnitude. No, the magnitude of the acceleration vector is not equals to the magnitude of the change in the velocity vector, but they always point in the same direction. Now, in order for one to determine the direction of the acceleration, they use the change in v. Okay, so you need to draw a motion diagram in order to determine the direction of the acceleration. So let's use the very same example that this example, where I said you have a car moving to the right at point A, it's moving at 5 meters per second, but now at point B, it is now moving at a different velocity. It's now moving at 10, right? So we said that this car must be accelerating, right? And then we measured the acceleration to be 2.5 meters per second squared. So now the question is how can we then determine the direction of this acceleration? We are going to use the change in velocity. Now at point A, we are saying that this object, it's moving to the right with an initial velocity of 5 meters per second. Okay, but now at point B, the velocity has now doubled. The object is now moving with a velocity of 10 meters per second. So the question is, how can we determine the direction of the acceleration? So this is what you do. You're going to take this formula. This formula says that your change in v is equal to v final minus v initial. But I can write this equation as v final plus negative v initial. So let's try and draw this thing on the diagram. So what you do, you are going to draw, let's just draw a small Cartesian plane here. So this is my small Cartesian plane. And then now I'm going to draw the two vectors. Now you're going to start by drawing the final velocity vector. So I'm going to start at the origin. The origin is my starting point. And then I'm going to draw the final vector. So the final vector, it's this one. Okay, this is the final velocity vector with a magnitude of 10 meters per second, right? And then when you're done doing that, at the head of this vector, you are going to draw the initial velocity vector. But now the initial velocity vector, it must be pointed. You have to change the direction of the initial velocity vector, meaning that your initial velocity vector must point in the negative direction. So this vector was initially pointed towards the right. So when you draw it on this diagram, it must be pointed towards the left. And don't forget that the length of the vector indicates the magnitude. So the length of the vector must correspond to the magnitude of the velocity. Okay, so like for instance, look at my final velocity vector. Right, it has a length of that, but now my initial velocity vector, I made it shorter. Why did I make it shorter? That is because the final velocity vector is greater than the initial velocity vector. Hence, when I draw this on a motion diagram, I made it smaller. Okay, so now my initial velocity vector, which is minus vi, it is equals to 5 meters per second, right? So when you're done doing this, you need to connect the two vectors from start to finish. There you go. You connect them from start to finish. This was our starting point, remember? So this was the start, and then this is the finish point. This is the final point. Okay, so when you connect your two vectors, you have to draw this vector from final vector to the initial vector. So now this vector that I drew in red is your change in the velocity. It is your change in velocity. Okay, so since our change in velocity vector is pointed towards the right, this simply means that your acceleration is pointed towards the right. Did you guys get that? Canva, did you understand what I'm trying to say here? All right. Miso, are you understanding? Miso, are you understanding? Just say yes or no. All right, that's fine. So now, here is it. Since my change in V is pointed towards the right, it means that the object is accelerating towards the right. Okay, now couple of pointers here. What you need to understand is that if the motion of an object, it is in the same direction as your acceleration vector, that simply means that the object is speeding up. Okay, you can get this in your exam or in the multiple choice. They can trick you with this. Okay, so important pointer: if the motion of an object is in the same direction, if the motion of the object is in the same direction as the acceleration vector, then the object is speeding up. It's speeding up. Okay, so if your velocity vector, basically your velocity vector and your acceleration vector, remember this velocity vector, it gives you an indication of where the object is going. The object is either going to the left or going to the right. So now in this question, your object is going towards the right. This simply means that the velocity is also in the same direction. Now, if velocity and acceleration are both pointed in the same direction, that means that the object is speeding up. Okay, and then if your velocity vector and your acceleration are pointed in opposite directions, this simply means that the object is slowing down. Just for example, let's say that we now have a car moving towards the right with an initial velocity of 2 meters per second at point A. Now, all of a sudden at point B, let's say that there's a traffic light at point B, and then the object slows down. Let's say now it's now still going to the right, but now with a velocity of 1 meters per second. You can see that it is slowing down, right? So let's try and determine the direction of the acceleration. You will see that the motion of an object and the acceleration vector, they are pointed in opposite directions. Hence, the object is slowing down. So now, look at it. Let's put it on a motion diagram again, just like we did with the other one. So this is my Cartesian plane. And then I now have an initial velocity of, okay, wait, before initial velocity, I know that my change in v is given by final velocity minus initial velocity. My final velocity is what? It's v2 minus, but I'm just going to put it as a plus, minus v1. So now v2 has a magnitude of 1 meters per second. So I'm going to start at the origin and draw a vector pointed towards the right. So this vector has a magnitude of, this is v2, it has a magnitude of 1 meters per second. And then now at the head of that vector, I'm going to draw v1. But now my v1 should be in the opposite direction. So that's my v1. And then v1, it is twice the magnitude of v2. Hence, you can see that the length of v1 is greater than the length of v2. So this is your minus v1 vector with a magnitude of 2 meters per second. So now we just need to draw the resultant vector from start to finish. Here is it. This was my starting point. So you now have your change in v. That's your change in v, right? So if your change in v is to the left, what can you say about the direction of the acceleration? The direction of the acceleration must be to the left, because I told you that change in v and your acceleration, they always point in the same direction. But the magnitudes are not the same. All right. So now look at it. The motion of an object is to the right. So the object is going to the right. This is the motion of the object. It's to the right. But now the object, the acceleration of the object is to the left. So what can you say about this object? The two are pointed in opposite directions, which simply means that what conclusion can you make? The conclusion that you can make here is that the object is slowing down. Object is slowing down. It's slowing down. Okay. I hope everyone is still with me. So let's proceed. Now, acceleration also occurs by changing direction. Can occur by change in direction. Okay, so now look at it. Look at it. Can occur by changing direction. Look at it. Let's say that you have an object going. So let's say that you have an object going in a circular path. Okay. So let's say that you have a bank, not a banked curve, but a circular path. So you have an object going in a circular path like this one. So what you need to know is that when the object is exactly at point A, its velocity vector is pointed due east. Okay, I hope you understand. So here is it. The object is pointed due east at point A, but now when the object is at this point here, its velocity vector is now pointed where? South of east. Okay, so this is the velocity vector of the object at point B, and when the object is at point C, okay, this is point B and this is point C, the velocity of the object, the velocity vector of the object is pointed due south. So at each and every point along the circular path, you can see that the object is continuously changing in direction, right? Let's make an assumption that the magnitude of the velocity vector is uniform, meaning that it's constant as the object is going around the circle. Let's say that it is constant and this object is moving at 2 meters per second. So is this object accelerating? Yes, it is accelerating because it is continuously changing in direction, even though the magnitude of the velocity vector is constant. Okay, so acceleration can occur by change in direction as well. Okay, so they will ask you in the exam. Make sure that you make note of everything that I'm teaching now, because you will be asked this type of questions in your exam rewrite. Right. So I hope that you guys are well. Now, let's carry on. Let's now dive into projectile motion. I've already explained what projectile motion is. This section is the simplest of them all, but students struggle with it a little bit. Okay, so I'm just going to try and simplify it for you guys. There's only few things that you need to understand in projectile motion. So I'm going to do it using an example. So let's say that you are standing on the ground. We are going to use the ground as our reference point. And then you have a stone in your hand. Okay, and then you project the stone upwards. So basically you're projecting the stone with an initial velocity of v, right? So now, Gutle, welcome. Zimi, welcome as well. I didn't notice that there are other people that joined the meeting. Nicole, welcome as well. I've recorded this session, so you can just go and watch the recording, because I've covered quite a number of things, because I'm moving a little bit fast, because Tafaza will be taking over very soon. He'll be taking you through mathematics. So I just wanted to give you a brief lesson on projectile motion. So yeah, so let's say that you're standing on the ground and we are using the ground as the reference point, and then you project a stone up in the air. All right, so you know that as soon as you let go of the stone, this stone will be in free fall, right? What does it mean when I say that the object will be in free fall? Now, free fall is basically one of the terms that we actually use in physics to describe objects that are falling under the influence of gravity, right? So any object that is falling under the influence of gravity, it is in free fall. All right, so you have a stone that is projected straight upwards in the air. So what will happen? What you need to understand is that the velocity of the object will decrease, right? It will decrease until it is equal to 0. Like here at the turning point, the velocity of the stone will drop to 0, right? But then the velocity will do what? The velocity of the object will begin to increase as the object is coming back downwards. All right. So I draw the trajectory of the object. I just drew the trajectory of the object here. So now, look guys, why is it that when you project the stone upwards, the velocity decreases? Why is that the case? You still remember what I explained about the acceleration. I mentioned that if the motion of the object, it is in the opposite direction as your acceleration vector, the velocity of the object will decrease, meaning that the object slows down if the velocity vector and the acceleration vector are pointed in opposite direction. So this simply means that the acceleration of an object as it goes up, the acceleration is pointed downwards, and I can prove it. I can prove it. So let's just mark 2 points on this diagram. So let's mark this point and let's mark this point. So let's say this is point A and this is point B. At point A, let's say that this object is going upwards with an initial velocity with a velocity of 2 meters per second. But now at point B, you now have the object moving at a velocity of 1 meters per second. So now, okay, let me use a dark color. So now this is V2 and then this is V1. So now look at it. The velocity is decreasing as it goes up. We want to know in which direction is the object accelerating. It is accelerating downwards. How do I know that it's accelerating downwards? That is because as the object is going upwards, what happens to the magnitude of the velocity vector? The magnitude of the velocity vector is decreasing, meaning that the object is losing momentum as it goes up. Okay, so now if we were to draw a diagram, let's put this on a diagram. We want to determine the direction of the acceleration. Let's put it on a Cartesian plane. Here is it. You have your change in V. We use change in V to determine that direction. You still remember, change in V is equal to V final minus V initial. And then everything that I'm writing, I'm going to give it to you guys, so you don't have to stress much about what I'm writing. Okay, so I think the important thing for you is just to take notes. Yes, take notes, because I can't write everything that I'm saying, but at the same time, make sure that you listen to understand. Okay, so I'm going to start at the origin. Now this equation here, this equation says that we must take the final velocity vector and add it to the initial velocity vector. Okay, our final velocity vector is v2. Our final velocity vector is v2. So you have v2 pointed upwards. It has a magnitude of 1 meters per second. So this is v2 with a magnitude of 1. But now we have to draw v1 in the opposite direction. But v1, it's double v2. Okay, v1 has a magnitude of 2. So now let's connect the two. Let's connect the two. So this was our starting point and this is our final point. Look at it. That's your change in V. This simply means that your acceleration is pointed downwards. Did you guys get it? Did you understand what I'm trying to say here? Can someone just say yes? No, open your mic, just say yes. All right, thumbs up. Seems as if people are understanding. They might trick you in the exam, especially in a multiple choice question. They can ask you, in which direction is the object accelerating when it is going up? Is it accelerating downwards or upwards? It is slowing down when it is going up, which simply means that it is okay. So when the object is going upwards, the magnitude of the velocity vector is decreasing. It is slowing down. Why is it slowing down? That is because of this. Is because the acceleration vector and the velocity vector, they are pointed in two opposite directions. And on this diagram, I've just proved that the acceleration is pointed downwards when the object is going up. Okay, but now when the object is at the turning point, here, is the object accelerating at the turning point? That's the question that we need to answer now. Is the object or is the projectile accelerating at the turning point? Anyone? What is the acceleration of the object at the turning point? Is it accelerating or not? The answer is yes, it is still accelerating. Even though at the turning point, as much as we say that the velocity at the turning point is equal to 0, here is it. You have a velocity of equal to 0 at the turning point. it is still accelerating, and it's accelerating with a magnitude of 9.8 meters per second squared. But the question is, how do we know that it's accelerating? We just need to prove it. Let's prove that the object is accelerating at the turning point. So let's just consider the 2 points. We're going to consider, this point. I'm just going to consider this point and this point. So just before the object could come to a stop, its velocity vector was pointed upwards. Let's say this object had a velocity of v1, and then on its way downwards from here to this point, the altitude on the broken line is equal. So it's moving with a velocity of v2, and the magnitude of v1 is equal to the magnitude of v2. Okay, so now you're going to use the change in v formula to determine the direction of the acceleration. Change in v is equal to v2 minus v1. So let's draw it on a diagram. If we draw it on a diagram, this is the starting point. My v2 is pointed downwards. That's my v2. And then, but I have to change the direction of v1. We need to change the direction of this guy here. We need to change the direction of that guy. So you are going to, at the head of this vector, you are going to draw v1, but v1 should be pointed in the opposite direction. There you go. This is minus v1. So connect the two. When you connect the two, what do you get? You get your change in v. This simply means that the acceleration, the object is still accelerating at the turning point. At the turning point, the projectile, it is accelerating, and it is accelerating with a magnitude of 9.8 meters per second. Okay, so at the turning point, the object is accelerating. Object is accelerating. It's accelerating at the turning point. Okay, now, and then its acceleration, it's 9.8 meters per second squared. Why 9.8? And what does the 9.8 meters per second mean? The 9.8 meters per second squared simply means that the object, it's gaining its momentum at what rate? So the velocity of an object, it's changing, or it is increasing by 9.8 meters per second every second. Okay, that's what it simply means, that your velocity is increasing by 9.8 meters per second every second for as long as it is in motion. All right, so let's move on. So in the exam, they might trick you in a multiple choice question and say, is the object accelerating at the turning point? The answer is yes. All right, let's carry on. Let's go back to our nice example. We have, this is you. We are using this as the reference point. You're standing on the ground, and then you have a projectile in your hand. So you decide that you're going to project this stone upwards with an initial velocity of v. So this object will follow this trajectory. It will reach a maximum point and then begin to descend. Okay, now there's only few things that you need to understand about the motion of this object. One, acceleration is always downwards, even though whether the object is going upwards or downwards, an object in free fall experiences an acceleration that is pointed straight downwards. I'm going to put it down. An object in free fall, oh, my handwriting, an object in free fall always experiences acceleration of 9.8 meters per second squared that is pointed downwards. Okay, I hope you guys understood that part, that the acceleration of an object is always pointed straight downwards. All right, that's number one. The second thing that I want you guys to understand, at the turning point, the velocity is equals to 0. So the magnitude of the velocity vector decreases to 0, decreases and reaches, decreases until it is 0, and then it begins to increase again, right? Now, if this object leaves this position with an initial velocity of v, let's say that with a magnitude of 1, when it returns, as soon as it reaches the same altitude as your initial point, the magnitude of the velocity vector should match up the magnitude of the initial velocity vector. Why is that the case? Look, if you draw a straight line like this, if you throw this object exactly at this point, if you throw this object with a magnitude of 1 meters per second, like when that object returns to the same position again, it will be moving at the same magnitude but in the opposite direction. Do you guys understand that? That is a keyword. That is very key in projectile motion. Just understand that the initial velocity is equals to the final velocity vector, but the final velocity vector is pointed in the opposite direction. But the question is, why is it that this velocity is the same as that? That is because the object is in free fall. When the object is in free fall, it is experiencing a constant acceleration, right? Whether it's going up, whether it's going down, it is still experiencing a constant acceleration. It's either it is accelerating and decelerating at the same rate. Hence, when it reaches the same altitude, it is moving at the velocity at which it left the ground. Okay, so this velocity is equals to that velocity. And then the other thing is that the displacement of an object between this point and this point is equals to 0, right? Displacement of that object is equals to 0. Remember when I explained the displacement, I said the displacement, it is the shortest distance to your destination. Now, you left this position and then you returned to the same position. Vertical, remember, we're talking about the displacement in the vertical direction. That's the reason why I'm using change in y. So the displacement along the y, it is equals to 0 because you are moving from the same position to the same position. This is like you right now. Let's say that you are in your room. This is your room, and then this is the kitchen. You are going to the kitchen to get some water, right? You walk from here to there. Let's say that from your room to the kitchen, it's 5 meters. So you get to the kitchen, you grab some water, but then you return to the same position. So you now move and return to the same position. It does not matter the path that you take when you return to the original position. It doesn't matter whether you're going to use the stairs or you're going to walk in a straight line, or you're going to walk to your sister's room and then use the other door to go to your room. It doesn't really matter. As long as you have returned to the original position, your displacement becomes 0. It is the same thing with what I just explained now. The displacement of an object, it is equal to 0. Why? Because you are moving from the same position to the same position. Okay. And then the other thing that is important for you to know is that the time it takes for this projectile to move from here to that point, it is the same amount of time it will take for this projectile to move from the turning point to that position there. All right, so meaning that T1 is equal to T2, right? If you can master those things, if you can master the few things that I've taught you, you should be able to answer any question on projectile motion. But there's still a part on graphs that we still need to do. Once we cover the graphs, if we can just cover the graphs, we would have completed this section. But the information that I've given you, it's enough for you to actually start solving the exam past papers. Okay, so it's a pity this is just a trial lesson. If it was not a trial lesson, I was gonna carry on and explain more stuff about your projectile motion. So the last thing that I can talk about is the equations of kinematics. So we have three equations of kinematics. The equations are as follows: V final is equals to V initial plus AT. And the other one says that V final squared is equals to V initial squared plus 2A change in Y. This is for the motion along the Y. And then change in Y, the last one says that change in Y is equal to, so change in Y is equal to V initial t plus a half A t squared. Okay, these are the only three equations of motion. I mean, in your test, in your graph paper, not graph paper, in your formula sheet, they normally write four equations, but they just rearranged. I think they rearranged this equation here. But these are the only three equations of motion that you just need to understand. Okay, so that's about it, guys. Yeah. Remember, this was just the trial lesson. I just gave you a glimpse of, the kind of work that we actually do. But obviously, when we start with the official lessons, we will be doing more. Okay. So please don't leave the meeting as yet. I'm going to hand over now to Tafaza to take you through Euclidean geometry. So he will, give you a taste of what we are doing. Okay, and then after the next lesson, please do not leave. We still want to talk about, we still want to give you more information about, the services that we offer into the students. So do not leave, stay behind, and ask as many questions as you can. And by the way, this session is free of charge. No one is expected to pay anything. And then everything that I've written, oh yeah, we've really covered a lot. So I mentioned that this is a 4 months intense program. Trust me, within three months, we would have completed the syllabus for physical sciences in full, including mathematics. So because we are that efficient. So if you are ready to learn, and if you are determined to work really hard, I can tell you right now that you're going to get that 75% or even 80% in the exam. All you have to do is to listen to us and take all our advices. So cheers, guys. I will see you again at 7 o'clock. Okay. Tafadzwa, I hope you are ready. You can take over now.
Can you guys hear me? Hi everyone. Matomo, is the mic ready? Is the audio clear from your side?
Yes, all is good. You can start hearing.
All right, perfect. All right, okay. Greetings everyone. I hope everyone is good. My name is Tafadwa, and I'll basically be taking you guys through a bit about maths, right? So today's focus or main topic will be on trigonometric ratios. That's the topic that we're gonna go through today, and just basically go through some key concepts that are quite crucial in the paper two. With regards to the paper two, we've realized that there's a big chunk of marks that are to be awarded in that section, and most students that's where they miss just under that um, they miss just under that, right? So we want to assure you guys that this section is not too difficult and is very doable, right? So the main objective of this lesson is to treat trigonometric ratios in such a way that after the session you'll be confident with it and you want to learn more and basically learn how to ace that. So I'll start by basically sharing my screen, and then we're gonna go through it step by step. And how we structure the lesson is we start off with a bit of theory, and then from the theory we understand the concept, and then from the concept we try to do practice basically few questions here and there that are not too bad, and then later on we'll do the much more difficult ones which are exam style ready. All right. Please let me know if you guys have any questions, and if you feel free to ask right away any questions that you might have. And if it's a question that's pending that you want to ask with regards to a question that you don't understand, that's maybe a bit too long, or you can also feel free to ask at the end of the session. Okay, so I'll share my screen. Please do let me know if you guys can see my screen. Okay, I think it should be visible.
Yeah,
All
all
right,
good. You can
perfect.
proceed.
Okay, so we'll start off with trigonometric ratios. Okay, so with regards to trigonometric ratios, right, what we want to focus on is just basically start off with the fundamentals, because trigonometry is a very connected subject, right? So what you want to do is to have a full understanding of the work that you are going to be dealing with, right? So before we even get to the ratios or the identities that you guys are tasked for grade 12s, right? We start off with basic concepts, right? So the first part would be understanding fundamentals, right? By now, you guys are maybe well familiar with Pythagoras, right? In terms of you knowing that, like, let's say when you draw a triangle, a right angle triangle, that's the first thing that you identify. What we identify is basically these three words: hypotenuse, opposite, adjacent. And why are these three things important for us? These three things are important for us because when we solve most of the problems based on trig, this is what we'll be looking at. So as you see here, I've given this triangle in quite a simple manner, right? That it has O, H, and A. What does that represent? We start here with sine. So sine theta would be equal to basically opposite over hypotenuse. I'm sure you guys are now familiar with this one. Cos theta is equals to adjacent over hypotenuse, and then tan theta is basically equals to opposite over adjacent, right? So we must keep these in mind. There's a reason why we want to have this as the first starting point in terms of trig ratios. Moving on, right, we have special angles that we know, right? So those are the special angles that we're also going to identify. Because as I said, trigonometry is a very interconnected subject. So what it requires that we cover the full ground by making sure that all bases are covered. So we go to special triangles, and one that has been introduced is what we call the equilateral triangle, right? So what's the equilateral triangle? It's a triangle that basically has all sides that are equal, right? For example, something like this, right? So what's special about this triangle is if I choose another pen here, right? If I cut this triangle in half, right there, right? What does this, how does it represent our triangle that we're going to investigate? Let's say, for instance, if I told you that each side is 2 centimeters long, right? It means that when I cut it in half, this side will be 1 centimeter and this one will be 1 centimeter, right? And what can we see? It looks like what? That Pythagoras triangle that we just drew here. So this is already a 90-degree, right? And then from there, we go and they say, okay, since it's equilateral, it means that all sides are 60, right? So this is 60, and that's 60, right? But we know something else. If this is 60, and I just cut this in half, can you guys see that the next thing we know is that here we have a 30. So we already start focusing to our main triangle focus. So this is a 30, 60, 90, right? So this is a special triangle, and the reason why it's special is, if you guys can remember, so that was just to show you guys where it comes from, right? But essentially, this is what you guys will be tasked to remember. So if you guys already have the hypotenuse, you have the adjacent, the only thing that's left to identify is the opposite side. And you can easily do that using the formula, since we know here that for any Pythagoras theorem, right, we have a formula that says a squared is equals to b squared plus c squared, right? What is the A? The A is the hypotenuse. B is either the opposite, or C is either the adjacent. Doesn't matter, either or is perfectly fine, right? So using the same concept, we can go back to this and try find what this value is, right? That's the value that we don't know, right? So we can put a kind of like a question mark to see what value this is, right? So we say what's A squared? So that would be 2 squared is equals to, this is 1 squared, and then we say C squared, we don't know what it is yet, right? And then we find that if we take the 1 to the other side, this becomes basically 2 squared is 4, 4 minus 1 is 3. So we find that C squared is equal to 3, therefore, from here, we can identify C as being square root of 3. So then that completes our triangle, and the first special triangle that we're able to find or to identify is the 2, 1 square root of 3. So this is the proof, as because I'm sure in your textbook you guys might have just seen it as a final formula being like that, and you might be wondering like why it's important to remember this triangle. Most of the questions that you're asked on based on trigonometry, when it comes to like, let's say, questions to do with simplification, or even you see later on when you do the harder questions, right? If you know how to prove this triangle, you won't even think twice in trying to remember which side is what. So it's quite important that you know exactly that you know this triangle at the back of your hand. Okay, so that's the first triangle that we have there. So now we go to the second one. So for now, I'm just going to touch on these two, right? I think there's one more that you guys should know, but for now, that's more of like in a special case is the 001. But the one which I wanted to make sure that I touch on is this 2, 1 square root of 3, and the other one is the 1, 1. So with the 1, 1 is basically when you have two sides that are equal in length and size, right? It means that this side and this side are exactly the same. Therefore, with that logic, that means each angle is identical to another. So when you have something like that, most of the time students forget what the hypotenuse is. And that's not an issue because we know how to solve for that hypotenuse because we already have two sides. So we can use the same concept in saying a squared is equals to b squared plus c squared. And then from here, we want to find what the hypotenuse is. So we're trying to find for A. So this is 1 squared plus 1 squared. We find that the answer here is A squared is equals to 2, right? Therefore, A is equals to square root of 2. So immediately, I write this as square root of 2. And right here, we have hit the finish of our special triangles. So knowing how to formulate these two triangles is quite important. So when you deal with problems that don't require a calculator, because most of the questions that are in paper 2 with regards to trig, all of them state how identify this angle without using a calculator, identify this problem without using a calculator, and the key to solving that question without using the calculator is understanding how each triangle is formed, so that when you see an angle, when you see a side, immediately you know where it comes from and how you can solve it. So whether this triangle is put upside down, because you know where it comes from, you can easily get to one of the sides or one of the angles. Okay, so once we know that there are special triangles that are involved with this, right, we can also then from there start giving a general idea of what to expect with regards to these Pythagorean triangles. So for example, if I draw a triangle like this, I can start making rules with this. Okay, so this is a part where maybe some of you might have seen or is a bit unsure of, right? So if I put a theta here, I'm going to stick this to now opposite and just the HOA so it doesn't confuse you guys, right? So where I'm getting at is that from here, right, we should be able now to play around with these and find the generalized formulas from them. So like we've said above, we know that sine theta is opposite over adjacent, right? Or opposite of hypotenuse. We know that cos theta is equals to adjacent over hypotenuse, and we know that tan theta is opposite over adjacent. From here, instead of giving you guys an angle, because this is 90, this is theta. I'll write this as 90 minus theta. And how do I get there? I know that the total triangle must give us total angle sum of 180. So what angles are in my triangle? I have the theta, I have this one which is 90, and I also have the one that I'm looking for. I'm going to call it x. So in the end, if I put this all at one side, it will form that x is equals to 90 minus theta. Hence, I wrote this as that. Okay, so we can call this angle 90 minus theta. Now, I want you from here, right? This is the first identity that you guys should be able to prove. If I write this side now as sine 90 minus theta, what does that equal? So sine from, so now we must shift our point of view. We're no more seeing this triangle in terms of this theta. We're seeing it in terms of 90 minus theta, meaning from here, this blue spot, right? So from sine 90 minus theta, right? What is sine 90 minus theta? It's just going to be a, and there's a reason why I kept it as the same symbols, is so that you guys can realize something. From here, what's the next thing that we have? We have cos 90 minus theta, which gives us what? Opposite over hypotenuse. And what else do we have? We also have tan 90 minus theta. And what does it give us? It gives us adjacent over opposite. And what's the importance of all this is so that you guys are able to prove that this is the same as that, and also this is the same as that. So that's the importance of knowing that. So in the end, when you're given any question, you should know that sine theta is the same as saying cos of 90 minus theta. Okay, so in a practical example, right, which I'm going to give you now, if you have something like, let's say, cos of 55, right? Cos of 55 is the same as saying sine of 35. Okay, so you guys see where that comes in handy when you have questions with odd triangles, right? When they ask you to prove something or simplify something, know that you can easily equate things like these together, right? Because of this rule. So it's quite important to see how we get there, and the understanding will help you then when you're simplifying stuff. Even it's not, sometimes you might have a long way of figuring things out, but remember in math, the key thing to solving or getting good marks is time, handling time. So if you're able to solve a problem as efficiently as possible with small amount of time, you're already halfway through the exam and halfway through getting a very good mark. Okay. So that's the first identity that I wanted us to spot, right? That so far into the session, does anyone have any question? Does anyone have anything they'd like to inquire with regards to what we just proved? Okay. If there's no question, then I'd like us just to continue and go to the next part. Okay. So now we know this, right? What's next? We are going to do the reduction formula. This is a very crucial part in terms of trig identities, because apart from knowing this 90 minus theta and theta, which is also very important in trig, another important thing is with these are the two things that will help you solve most of the problems in your exam papers. So this is how you just draw this one. So what you do is you draw a Cartesian plane. And then from the Cartesian plane, what you want to do is you start, the Cartesian plane is split into basically 4 quadrants, right? The first one being what we call, or what you guys might have seen as A, right? It means, it represents basically all angles, right? And then in the second one, it's S, and we call this one T, and this one is C, right? So I'm sure you guys might have seen how to solve in terms of using this quadrant formula. But what I want us to get is to understand really how some of these are formed, right? So from using the ASTC method, right, we start off with our first triangle, right? This triangle, like I mentioned, it represents everything. So it represents all angles that are positive in this quadrant. So we start off by saying theta. So theta is basically positive in this first block that we have here, right? So from here, since we know that it's basically theta, right, we can basically draw like an x to represent our x direction and our y, right? And we know that this is r, right? And you're going to see the importance of writing this as x, y, and r. So x, y, and r are all positive in this quadrant. Hence why everything is possible, whether it's in terms of sine, cos, tan, or any of those, it will be positive in that first quadrant. And what's important or what's crucial to take note here is that this basically occurs from between 0 degrees, right, to 90 degrees. Okay, so that's the first quadrant. Understanding that it goes from 0 to 90 degrees. The next thing that's to note is the second quadrant, which goes from 90 to 180. So what's special about this quadrant? Well, it's specific to S as shown in the diagram. So let's understand why it's specific to S. So if we continue, right, just drawing our second triangle, we'll see that basically in terms of this one, right, remember we're working in a Cartesian plane. So whenever we work in a Cartesian plane, we start from this position and go all the way right round to here. So where this stops is the angle that you're kind of looking for. And can you see that this angle is an obtuse angle? What's an obtuse angle? Is an angle, remember, it's between 90 and 180 degrees. So this blue represents that, right? So instead of saying theta, we'll call this K now, the reference angle. This is where it comes in. So from here, we can continue labeling our triangle. So this is now R, this is Y. And notice that both Y's are positives as they are both in the Cartesian plane, they are above 0. But can you see that X is positive on the right side, but on the left-hand side, X is negative. So if X is negative, what importance does that have on our triangle? That means that, like, let's say, for instance, let's take sine. So sine of K, for instance. So sine of K is basically equal to negative X over R. So can you guys see why sine is basically like, let's say, not sine, sorry, this is cos. So because remember, cos is in terms of adjacent, and x is adjacent in this triangle, right? So if you take cos of k, right, you'd see that this is negative x over r. So you guys can see why sine is the only one that's positive in terms of this quadrant, because if I say opposite of k, it would be y over r, which is positive. If I take tan, for instance, it's going to be minus x over minus y, which is what? A negative number already. So that's the reason why we say sine is the only one that's positive in that quadrant. Then we go down into the third quadrant. And then, like, once again, what's special about this third quadrant? We start again by continuing our cycle. So our cycle starts at this position, goes all the way that side, then stops right there, right, at that reference angle. So why it stops there, this one we call a reflex angle. Reflex angle is basically just above 180 degrees, right? And something that I also didn't take note here is that in all of these quadrants, right, we started with theta here, right? In this one, it would be 180 minus theta, right? And the reason for that, remember we said it's an obtuse angle. So whatever value for theta you have to subtract by 180 in this quadrant. And then in that quadrant, because it's above 180 degrees, so it would be 180 plus that reference angle. Okay. With that being said, we go again here, but what's different here is that, can you see minus x is still on the left hand side, but what's special here is that you have minus y because it's going down. is below the 0 axis, and this is r. So say for example, if I have cos, so cos of k, right, is just gonna equal to cos minus x over r. What about sine? Sine of k is gonna equal to minus y over r. Can you see both of them are negative? How about tan? Let's see if our rule still applies. So tan of k is equals to opposite, which is negative y, over minus, just rewrite it, over minus x. So can you see a minus and a minus makes a positive? So this is y is just going to become y over x. And this is why tan is positive in that quadrant. Okay. So that's the importance of having that there, right? And as you can see, bit by bit, in understanding the reduction formula, it will increase your abilities in order to solve some of the simplification questions that we're gonna do together. Okay. Then lastly, in this quadrant, we call it the cos quadrant, we basically have theta, sorry, not theta, k, right? And in terms of k, remember, we continue with our revolution, and it goes all the way up there, right? And in this, what's special about this one is that this is basically almost 360, but it doesn't reach 360 because of that k. And therefore, with that reasoning, this will just become 360 minus theta. So when you're working out the reduction formula in terms of finding the angle in that quadrant, you always need to remind yourself that it almost reached 360, but didn't because of the theta that was there. Hence, we subtract minus theta there. Okay. And then here we have negative y, but can you see here it's going to be positive x because we're on the positive side. Hence, that cos is positive in this quadrant because can you see that if you see x, think of it representing cos, and if you see y, think of it representing sine. So if x is positive, right, cos is always going to be positive, but if y is negative, sine is going to be negative. They go hand in hand together. Okay. And yeah, that's pretty much it with regards to the reduction formula. And its importance, right, is when you're solving generally trig questions, right, you must remember this formation deeply. Say for example, like let's say when you look at it in terms of solving a question, whatever trig question that you get, right, always make sure that you draw this quadrant here in small, and remember that it's A, S, T, C. Remember what's positive. When you solve a trig question, you're always going to get two answers. So say for instance, if sine is positive where? The first and the second. Let's say for instance, if I get an answer that has 10 as negative, where is 10 negative? 10 is negative here and is negative here. So just remember that to always draw your small quadrant so that you can solve the problems as efficiently as possible. Okay. Now, let's just do small example problems so that we can just see how this helps us. Basically going to the reduction formula and also testing special triangles and with regards to the 90-degree rules. So for instance, number one, if I have a question that has sine 120, for instance, right? How do I solve it, right? Some of you might be like, oh, that's a very simple one. I've seen this question so many times. I know what the answer is. But the step-by-step breakdown of this by using what we just learned is by saying, okay, if I have 120, right, let's solve it in terms of the reduction formula. Where is 120 in this quadrant, right? 120 is greater than 90 but less than 180. So that means we're dealing in which quadrant? This one. So the first thing that I'll write is sine 180 minus theta. Okay. And then after writing that, how can I solve the problem? can you see 120 must equal to that? So the first thing that you want to do is find what theta is. So what you can just basically do is on the side just say, therefore this means 120 must equal to 180 minus theta, right? And by doing that, you can easily identify that theta, this means that theta is equals to 60 degrees, right? So this simplifies to just sine of 60 degrees. And what do we know about sine 60? This looks familiar. It's a triangle that we've actually dealt with, right? So if we actually go down here, you'd see that on the special triangles, I have a 60, 30, right? This is the triangle that I'm dealing with. And remember, like what I said, if you know the ins and outs of this triangle, immediately when you see sine 60, you know, okay, this one is what? Opposite square root over 3 over 2. So the more practice you have in understanding this triangle, when you see something like this, immediately in your head, it should like just come across. So you know that this is just gonna be square root of 3 over 2. And then there you have it, you solved it without using a calculator. And then, yes, hi?
Sorry to disturb you. I wanted to ask why
Yeah.
the quadrant.
So I couldn't quite hear that.
Because we're dealing with sine 120, right?
Yeah.
And quadrant A uses degrees which are greater than 90, right? Then why
Yeah.
didn't we use that quadrant? Why are we using the 180 minus quadrant instead of the theta quadrant?
Okay, yeah, the good question. So the reason why we're using the 180 minus theta quadrant, it comes back to what angle did you receive? We received the angle that was 120, correct? Which is this one. So where is 120 in the Cartesian plane? It's right here. So that's the first thing that you must adjust. When you have a 120, right, or you have an angle that's greater than 90, you must always locate it in the quadrant. So where is it? It's between 90 and 180. So it means that you just look at the green areas, right? So if you have 120, it means I'm in the 180 minus theta quadrant. And then from there, you solve it using this like methodology of saying, okay, that means I must write it in terms of this. And then once you have it like that, you simplify the theta, and then you are able to solve your problem. Does that make sense?
Yeah, I understand it now. Thank you.
All right, perfect. Okay. And then let's just switch it up a bit for this one. I want to have an answer that's negative. So let me try to do an answer that's negative so that you guys can also see the effects of having a negative answer whilst being in a quadrant that let's say the cos or the sine is not comfortable with. So let's say for instance I have something like cos 135, right? Where is cos 135? Let's look. So remember what we said, the first thing, let's locate where the 135 is in the quadrant. 135 is greater than 90 and less than 180. So can you see again, this one falls within the same boundary. So what do we write now? We write cos, so we write here cos 180 minus theta. And then what do? We go to the side again, and then we say 135 is equals to 180 minus theta. So what is theta? So therefore theta should be equal to 45. Okay. So that means here we just say therefore cos simplifies to 45. And then from here, what do we know? Remember, this is where you guys must not make this mistake. So can you see already, I already equated 180 minus theta, right? And I already said, okay, I found my theta, but when you're going from this step, from the first to the second step, another thing that you must consider is where is cos positive or negative in this quadrant. That's something we didn't address in the first one because sine was positive in that quadrant. But if cos is in this quadrant, it's negative. So immediately when you go in this step, what you do is basically simplify it and write it as minus cos 45. So you must be careful with, especially when you're dealing with a problem that the cos or the sine with the tan is a negative quadrant in. So since we know that cos 180 minus theta needs to give a negative answer, if you want to, you could have already put a negative before you even found out what the theta is, so that you remember that. Because the common mistake is to always just simplify it as cos 45 and then solve for the problem. So once you have the cos 45, another thing, remember the importance of those triangles, the special triangle. We know what's a 45 triangle. So what's the cos of 45 here? So it's just going to be 1 over square root of 2. So here we just write here minus 1 over square root of 2, and then that's your answer. Does that make sense, guys? Any questions there? Okay, and please feel free to unmute yourselves if you have a question, or just raise your hand if you're not sure about something or you have a query with regards to the content. So what's the next thing that I want to do? I want to give a question that is slightly different, right? So we dealt with a question that was inside that second quadrant, but what if we have a question where, for instance, that's slightly different, right? So slightly different how? Let's say, for instance, if I have cos of let's say, for instance, if I have tan of 225, right? How to solve that?
Tafaza, sorry to
Again.
interrupt. There's a question.
All right. Yes, Lilita. Sorry. Am I the only one who can't hear? I think try unmute yourself. Mute yourself and then unmute yourself again. Hi, Matoma, can you hear?
Negative.
Negative. All right. Lilita, can you try one more time again, and then maybe you can continue? All right. Maybe try type your question on the chat box that we have on the Teams, and then we'll get back to you if you're successful with it. Okay. So with regards to the 10225, right? Remember the first thing that we said, the first step is trying to find the quadrant that we're in. So 225, where is it in the quadrant? It's definitely bigger than the first and the second. Let's see in the third. Yes, we're in the third quadrant because we're greater than 180, but we're also less than 270, right? So from there, we can basically identify this by saying, okay, therefore this means that tan is basically 180 plus theta. And then on separate here, we say, okay, since that's 180 plus theta, let's rewrite this then as 225 is equals to 180 plus theta. And the whole purpose of this is so that you find what theta is. So therefore theta is again equal to 45. And remember the importance of always checking whether what you're solving for is it positive or negative in that quadrant. We know tan is positive in that quadrant, so our answer is perfectly fine. So immediately we can just simplify this to tan of 45. Okay, so the whole point in doing what we do is so that we're able to solve the problem easier, right? By linking the angle that we have to theta. So once you find what theta is, can you see that we are able to solve it because we know the special triangles? But we must be careful that we find the right one, whether it's positive or negative of that. So from tan 45, we can go basically to our triangles, and then we find that tan 45 here is just basically going to go to opposite of adjacent, so it's basically going to be 1 over 1. So the answer here is just 1. And then there you have it. And remember, we're doing all these steps without having to solve for a calculator. Okay. Any questions? All right. If there's no questions, right, now we've just solved these simple ones. I want us to maybe try one of the more harder exam style questions that I think some of you might have seen, right, in this, the way they structure them. So we'll get a chance to do maybe one or two of them, but I want us to at least touch some of them so that you guys are also, you can see the direction that you take when solving some of these. So, and the importance of what we were doing when we're solving this bit by bit. So can you see this all adds up to the bigger picture when you're now given or asked a question to solve that has basically all this in one thing now, right? So now this is all now expressed as a fraction, right? So that's the importance of this. To be able to now solve this types of problems that are now basically condensed into a single fraction or a single identity. Okay. So from here, right, we have question 1, which is basically something like this. And then we say this is basically going to equal to sine 180 plus x, right? And then from 180 plus x, we basically have cos of 330 plus tan of 150, right? So we want to find here from here how to simplify this problem set, right? And when you simplify this problem set, right, we want to basically be able to use all the theory that we just basically learned in this first session. So what we do, my advice is usually when you have questions like this, right, your your target is to always try to basically solve it by breaking it into small parts. So for instance, wherever you see a multiplication, remove that multiplication and remove the question. So how I would solve this is by saying this first one would be, let me first solve what sine of 180 plus x. Okay, so what sine of 180 plus x, right? If we take a look at the quadrant that we're in, let's look at the quadrant that we're in. 180 plus something means we're in the third quadrant, right? So already that means that we're here, right? Is sine positive or negative there? Sine is negative. So immediately we know this is just going to equal to minus sine x, right? Right, we have solved that. Let's go to the next part. What is cos 330? So cos 330 is just basically equal to, if you look above here, right, we can basically look at these quadrants again, and we can immediately identify the 330 as being in the fourth quadrant, right? So in the fourth quadrant, we can see that like from here, we should be able to deal with this problem quite simply actually, because we know that if we take it to the side, right, we can see that 330 is equals to 360 minus theta. For now, we're doing it the long way, but you guys will see with time and practice, you'll be able to solve these problems. If you just see a 330, we know that already theta is equals to 30 degrees. So here, I would simplify this to cos of 30. Okay. And then what's the next one? Tan of 150. So what is tan of 150? Tan of 150, again, similar concept as to what we just did here, right? But can you see that 150 is in the second quadrant, but tan is negative there. So immediately we rewrite this as a negative tan, and then what is 150 in this with regards to this. 150 would be equal to, if you do the math, you should find that it's going to be 180 minus 150, so it's just 30. So in the end, you just rewrite this as negative 10 of 30. And then sine x remains the way it is because we can't really simplify it further. So now let's redraw our fraction. So this is just going to equal to minus sine x multiplied by cos 30 multiplied by minus tan theta, 30, sorry. And then all those is divided by sine x, right? So can you see from here, we can basically cancel these out now, because these are the same, right? And then what do we know about this? This is now in a very favorable position, because what do we know? We know that basically we can find what cos 30 is, and we can also find what tan 30 is. So from here, we can basically find the actual value to, right? So starting with basically the 30. So we say, what's cos of 30? If you go back to our triangle, special triangle, we go to the 30 degrees. What's cos of the 30? It will be just square root of 3 over 2. So we write this as negative, because the negative comes from that sign there. So it's going to say negative square root of 3 over 2 multiplied by negative. So what's tan 30? If you go to the triangle again, tan 30 is going to be opposite, which is 1 over square root of 3. And then once we have that, we can see that these square root of 3's will cancel. So immediately now after this, you'd be left with basically a half. Okay. And can you see we have solved all that without even using a calculator? Okay. Does anyone have any question? Does it make sense? Yes, Lilita, are you able to unmute yourself?
Yes, can you hear me now?
Yeah, I can hear you perfectly fine.
Oh, yes, yeah, I have a quick question, sir. So if you have like, see there we are given that sine into 180 plus x. So if you are given a quick question that says, okay, sine into 510. So how do we solve that one? Do we minus it with 360, or we use
Yes, yeah,
our yes,
yes, that's a very good question. So let me just quickly, before we answer that one, let's go back to where we're solving the questions, right? So say for instance, like you said, if we're given a question that's not within our boundary, because remember here we're working from 0 to 360, right?
yes,
So we're like, oh, okay, we're given now 590 or something like that, something that's above 360. So when
yes,
you're given something like that, you always subtract 360, because think of it like this, right? If I start at this position, right, and I have a full revolution, that's 360. But then
yes,
let's say I add 30 degrees. Can you see I've done it 390 degrees, but I'm in the same position as someone who has 30 degrees.
yes,
So when you have something like cos, let me just write here, the bottom here. So if you have something like cos of 510, right, what you want to do is to just say, let's minus 360 again. So you say cos, then you now say you have 510 minus 360. So once you have now 510 minus 360, now you should be able to now solve it in a way. Let's say, for instance, after you've done this, what answer should you get? Get 0. Wait, let me get 0, and then 5, 150. You have cos 150, right? So from cos 150, can you see now it looks familiar to the ones which we had?
Also,
Looks
Koyo's 150 is from the first quadrant to the second quadrant, is from 90 to, is between 180 and 90.
Yes, yes. So can you see by subtracting that 360, we've put
Yes,
it in a space that we're familiar with.
yes, I can see it, sir.
Yeah, so then you now solve it you solve it the same way that you've been doing the others. And that applies even if you have something like cos of 750. Can you see 750 is a very big number? So
Yes.
what you do is you subtract 360. And then if you're still out of bound, you subtract 360 again. So the essence of this thing is you can subtract as much 360s as you can, as long
Oh,
as you get to the point where you are in the same quadrant, in the between 0 to 360.
and I understood, sir. Thank you for the answer, sir.
All right, perfect. Anyone else with a question? Okay, if there's no question, let me try. Yes, is it non-tando? I think you are unmuted. Do you have a question or it was an accident? Okay. If there's no question, then let's just continue. So what I wanted to do is I wanted to do one basically that, let me just, I wanted to do number 3 because the reason I want to do number 3, I want to do one that is also as a negative so that you guys can actually see that when we also have a negative, how are we able to approach it, right? So we can basically look at it from here. Okay. So that you guys don't have to scroll up and down. So number 3, this is one that's also quite good because there are many different variations to this one. So we have a 10 480. Without going or spending too much time on it, let's break it down. 480, right? Like I think Litas initially asked right now, right? So 480 we know is way above the 360. So what do we do? Like I said, remember, we subtract. So the first thing I want to do is subtract 360. So if I subtract 360 immediately, 480 minus 360, I get 10 of 120. Okay? I get 10 of 120, right? That means it looks more familiar. I'm more comfortable with a question that's like this, right? And then what's the next thing that you do is basically say, okay, from here, right? What do you have next? We basically have, let's see. The next thing that we have is sine of 300, right? But before we even get to the sine of 300, we can actually simplify this one even further, right? So for instance, here by the 120, we know which quadrant it is in, right? It's basically in the 90 to 180. But remember, it's 10, so it's negative. 10 is negative in that quadrant. So immediately, I'll rewrite this as negative 10 of 60. Okay? And then once I have that figured, I'll go to the next one, right? Where I say, okay, from here, how do I basically get to sine of 300, right? So I'll say sine of 300 is basically equals to, where am I in the quadrants? It's less than 360, so I'm fine. But can you see it's within this fourth one? But only cos is positive there. So immediately when I deal with this one as well, I know I must put a negative, right? And this is 360 minus theta. So therefore theta is gonna actually be equal to 60 degrees as well. So here, I'll just put 60 as well. So it's negative sine of 60. And yeah, what do we have? I have cos of 14. So for now, I don't know what to do with that 14 degrees. Hopefully, we'll be able to solve it. Sine of minus 135. What can we do with this negative? Okay, So when you have a negative, right, what does that mean? It basically means, especially for sine, a negative in sine means it's going to just stay as a negative, right? So this negative 135 means that if I need to take it out. So when I take it out in the bracket, it just looks something like this, minus sine of 135. That's what this basically means. When they put a negative inside the bracket, it means take it out for sine. But if we're talking about cos, if this was cos minus 135, right, it would actually stay the same based on the rules and the proofs. Okay, so sine of 135, right? Forget about the negative, just look at sine 135. This looks like what familiar because it's in the quadrant. Actually, we had solved this one earlier on. So you can just, oh, but you said in terms of cos, but essentially it's gonna just be sine of 45. And we know that sine is positive in that quadrant, so we don't have to worry about that. So it's just gonna become sine of 45. Is there another thing we need to solve? So so generally when you're solving these, it's always a good idea to take these so that you can basically see what you can simplify. And then you have now sine of 104. So if you have sine of 104, what does that become? Sine of 104 doesn't really have like it doesn't really have like a simplification, but what you can try to do in a question like this one is do the same thing, right? You basically say 180 minus theta, so therefore this would now become sine of 180 minus theta, right? And then you find that theta is equals to 76, right? So sine is equals to 76, right? Then that's fine. And then lastly, we have cos of 225. I think cos of 225, we had solved it actually earlier on as well. So this just becomes that. And we find that we're going to get cos of 180 plus 45. So as you can see, we have simplified it to a point where it's steadily we're basically gaining marks. So for doing all this, right? Can you see, guys? This is a 9-mark question. You have solved about half of it, right? You've gotten 4 marks at least by writing all these steps down, and this is relatively simple based on what we're doing. So at times when you're approaching these questions, just try break them down slowly but surely, and then your marks will come. Okay, so let's rewrite this in terms of that fraction. So it's going to be minus tan of 60 multiplied by negative sine of 60 multiplied by cos of 14. We're going to see why it's important. And this sine of negative just became negative sine of 45. And then all this over sine of 104 is just sine of 76. And then this is multiplied by negative cos 45. Okay, so out of this, right, we can simplify a lot. We can simplify this, we can simplify this, and this. So the only thing that's left is this 14 and 76. So this is where now we go back to the drawing board and see we have done as much reduction formula as possible. But what's another thing we did? This triangle, right? And what did this triangle teach us? This triangle taught us that if I have sine of theta, right, it's equals to cos of 90 minus theta. Right. So if we draw a triangle, let's say we draw a 76-degree triangle. So meaning, like, let's say, what I mean by that is, if this is 76 degrees, right, and this is 90, what is this angle, right? What's 90 minus 76? And that's when you realize this is 14. So can you see already now, I know there's a link between this and this. And what did I say about that linkage? That linkage basically said that if I have a sine theta, it must equal to the opposite angle, but also in terms of if you have a sine sine. So you choose this one, and I'm not gonna rewrite the whole fraction. I'm gonna rewrite this as basically sine of 76, because it's basically the same thing. And when you do that, you realize then now you can actually solve everything of this problem. This is cancelled. These you can use basically like, let's say, the identical triangles, the special triangles that we've learned. And then in the end, I also leave the math to you guys, but you should be able to basically get something like this, where you say this tan of 60 in the special triangles, you should be able to get negative square root of 3. How I get that, I just look at this small triangle here and I say, okay, what's tan of 60? It's square root of 3 over 1. So that's just a glimpse of how to solve then all of these step by step. So I'll do the same with this say sine of 60, right? And that gives me minus square root of 3 over 2. And then remember I said this is cancelled, so I don't need to worry about this. I'll just leave it like that. Sine of 45, I can find also the other triangles, right? And this will all over be the cos of 45. And this is just minus 1 over square root of 2 again. And then this is just going to be simplified too. And can you see I'm solving all these without a calculator, as I expect you guys to, right? You say then this becomes square root of 3 times square root of 3. Remember, a square root or times the square root gives you the third is gone. So you just be left with 3 over 2. Then that's your answer. There you have it. We have all 9 marks. Okay. Lilita, is that a question?
Yes, I have a question.
Yes.
Yes, I have a question there. But you said we have negative sign most. What is it? Sir?
Sorry. I think someone unmuted. Yeah. You're saying you have a negative sign. Yeah.
Oh, well, I see that it's sign into negative 135 now.
Yeah.
And 135 is in quadrant 2 is between 90 and 180.
Yeah.
So I saw that you took the negative out, and the sign
Yes.
was negative, and you
Uh-huh.
you told us before that sign is positive at quadrant 2. Ne?
Yeah.
So what was gonna happen if it was not sign, if it was cos into negative 135?
Yes. That's a very good question. So I'll just quickly solve that. We're almost running out of time. So if this was the exact same question, right? And let's say you've reached to a point where it is now something like minus cos of 135, right? For instance, what do you know about cos? Cos is negative here, right?
Yes.
So what would happen is that you treat this as a bracket. So you'd say then this is minus, and then you solve your answer inside this bracket. So this is just minus cos of 45. So it was actually going to become minus times a
Yes.
minus, which is
Is
a
it
positive.
positive? Oh, okay, I see. It's a thing. Thank you.
All right.
Thank you.
And yeah, if there's no other question, thank you guys. We've come to the end of our maths trial lesson. Please do feel free to inquire more and just there's just a glimpse of what to expect and in terms of our structure and our approach. This is how we do it. Most of them by far, 16,000. Nokukanya, do you have a question? And then all right. If there's no question, I think, yeah, from my side, that is it. Thank you guys for joining us. I hope you guys got to have a good taste of what to expect. And please do feel free and join us so that you take part in our rewrite bootcamp sessions. And yeah, hopefully we'll definitely get you guys to get those high marks that you guys want. All right, Matome, over to you. Any?
No, thank you so much, Tafazo. for that amazing lesson. Yeah, you've really covered quite a lot of content in there. So you've compressed the lesson. But students, please don't be scared. We won't be moving this fast. I hope, Tafaza, you won't be flying like you were. You will try and slow down a little bit. Yeah, so that the students can
Yeah.
easily digest the information. So let's just wait for the next 2 minutes or so, because I invited the parents to join the meeting just for the information session, because I did not really do any introductions because I wanted to get going with the lessons, and I wanted to reserve this part for the for 7 o'clock, because we understand that some of the parents were still traveling from work. So let's just breathe for 2 minutes, and then we'll get going with the information session. Okay, so whilst we await for the parents to join, to all the students who will be rewriting mathematics and physical sciences and hopefully other subjects, how did you find the first 2 lessons? And just comment on the lessons that we've just presented. So anyone can go ahead.
Hi, hello.
Hello, Zimi, how are you?
I'm good. How are you?
I'm also good.
Well, I came in late because of load shedding, so I didn't really grasp much from the physics lesson, because when I arrived, a lot had been done already. I was very confused as to what was being done and so forth. But regarding the maths lesson, I really enjoyed it. I got to understand a lot more, because I realized that in the past I was just doing things because I was taught that they were done a certain way, and not because I understood the way in which they were done. And then here I got to understand why we were doing stuff the way in which we were doing them before, and why certain questions were worked out in certain ways, and etc. So I enjoyed the maths lesson. I'm looking forward to actually being part of the physics lesson, because I can't say much about it because I didn't
Yeah.
much. Yes.
No, thank you for that beautiful comment. I think I remember you joined towards the end. So it was really to put the pieces together, because I had already covered quite a number of things. But thank you for that comment. So anyone else would like to go ahead and comment on the 2 lessons? And parents, welcome. Anyone else would like to give a comment? Good or bad? Even if it's a bad comment, I mean, we will welcome that comment and work on it. Anyone? Canva, Gutle, Lilita, anything from your side, guys? Okay, Nontando, you want to say something? You can go ahead. We can't hear you. Are you saying something? We can't hear you. All right, no, that's fine. So thank you all for coming, and welcome students, welcome parents. So my name is Madume Malachi. I'm originally from Limpopo, but I'm based in Cape Town since I left home more than a decade ago, because I wanted to see what the other people are doing out there. So I'm based in Cape Town, and in terms of qualifications, I've completed a BSc in physics. I also have an honors degree in chemistry, and I also have a BSc engine chemical engineering degree, and I'm a potential graduate at the University of Cape Town. Yeah, I'm just in the process of completing my Master of Science in Chemical Engineering. And then in terms of teaching experience, I've been a tutor for the university for quite a while now. I think in counting, I've been a physics tutor for 9 full years, and I've been tutoring, advanced engineering courses and chemistry courses for as long as I can remember. And then in terms of high school, I've been teaching physics for as long as I can remember, including chemistry as well. And I am the managing director of Uhandisi Tutors. So I will tell you a little bit more about the tutoring company. So I'm working with Tafazo. He is also one of the directors of the company, but the branch that we recently opened, which is the metric upgrade program for the students who are looking to rewrite the metric. So Tafazwa, you wanna take a minute to introduce yourself before I can share more details about the company?
All right. Thanks for tuning. Hi, everyone. I am Tafazo Mashamba, as he introduced me earlier on, and basically I am a master's candidate in engineering. Just completed my Bachelor of Science in Chemical Engineering in the last year or so, and throughout my course of and throughout my undergrad tenure, I've basically been tutoring and basically going through some university students as well as high school tutoring. And so, yeah, I'm pretty excited for all you guys to join the team and also help upgrade the students and basically go forward with good results in the future. Thank you.
Thank you for that, Tafazo. So I just want to tell you a little bit about, what we do, the company, about our company and what exactly we are doing. So the name of the company is Uhandisi Tutors. So Uhandisi simply means engineering, for those of you who do not know. So when I started this company, I wanted it to sound African, So then I was like, okay, I wanted to call it engineering tutors, but I was like, okay, let me find, um, the word engineering, but you know, in the 11 official languages, it is difficult for you to find, the meaning of engineering. Translating engineering into my mother tongue, it was difficult, even in the other languages that we have. So then that's when I spoke with my friend from Kenya. She was like, okay, in Kenya, they call engineering uhandisi. There was like, yes, we're going to go with it. So engineering tutors is the same as uhandisi tutors. So this company was founded 2 years ago. And when we started, this company was mainly for offering, tertiary courses, mainly your mathematics and your tertiary physics. But at some point, we decided that, you know what, we can really contribute a lot in the high school space as well as in the primary school space as well. So the curriculums that we cover are your normal South African curriculum, which is your CAPS, your IEP, but we also offer the Cambridge A-level curriculum and then AGCSE as well. So we also do take international students as well. So, most of the international students, they complete the Cambridge curriculum. So we do take them on as well. And then we recently decided to launch the Metric Upgrade Program. So the main reason why we launched the Metric Upgrade Program is because at the University of Cape Town, for example, they receive over 100,000 applications each and every year, but there's only roughly 4,500 spots that are available for the first year students. So basically 4,500, it's roughly is it 5% or less than half a percentage of the total applicants? Yeah, it's about more or less 5% of the applicants. So meaning that whenever you put through an application at UCT, so you only have a probability of 5% that your application will be successful. So they strictly want distinctions. So if you do not have distinctions, then it becomes very difficult for one to get into UCT. So that is the reason why we started this program, because we want to increase, or we want to assist, the students in order to get into into UCT, not just UCT, but in the top universities in the country. So that is the main reason why we started this program. So in this program, we are offering one-on-one lessons and group lessons. So I think I did get in touch with most of you. I did mention that our group lessons are only limited to mathematics, physical sciences, and also accounting. So we've set the price to be 390 Rand per month. However, let's say that you cannot afford 390. So just come and talk to us, because, you know, this program is less about the profit and more about making an impact in the lives of, you know, in the youth of South Africa. Let me put it that way. So just reach out whenever you feel like, you know, you don't have enough or you can afford a certain amount. And besides, I mean, we're still getting started. So yeah, so we want to invest in your future. So please make use of this program. And then we also offer one-on-one lessons. So if you feel like you need, you know, that individual attention, undivided attention, then you can book one-on-one sessions. But one-on-one sessions, they are a bit pricey, but let me not say a bit pricey, because expensive or a bit pricey, it's relative. So but we charge 230 Rand per hour, but obviously if you're taking ours in bulk, then we tend to discount accordingly. And the subjects offered in one-on-one lessons, you know, we offer quite a large, or let me say we have quite a range of subjects that we offer. So the spectrum is a little bit wide in terms of the subjects. So yeah, more or less, you know, almost all the subjects, you know, all the common subjects have been offered in the one-on-one lessons. And in terms of the success rates, we've recorded over 90% pass rate with tertiary physics. As you all know, physics is a little bit challenging. At high school level, it's not really challenging, but you know, it is one of those heavy subjects. But at tertiary, last year we've recorded a pass rate of over 90%. We are doing this also for tertiary courses, mainly your first year mathematics, your first year physics at the University of Cape Town, and our students are really doing well. Yeah, and then in terms of high school, the pass rate for grade for high school level in general, it was good, but there was a problem with Sakai last year. For those of you who were attending the UCT online high school, I'm sure you know, Sakai messed up the results somehow, but nevertheless, most of our students, they did pass, but some of them, they were not really happy with the grades that they obtained. But we do have a few students who actually made it to UCT, to VETS, to UJ, and some of them even secured, you know, bursaries before they can even receive the official final offer from the universities that they applied to. So just to name a few students, I can't mention names, but we do have students who have received bursaries from Sasol, from not Anglo-American, but from Daliot and municipalities, Western Cape government, and so forth and so forth. So if you want those testimonies, I mean, you can reach out and I can, you know, share some of them with you, but they will be made available once our website is ready. I'll tell you more about our website shortly. And then what exactly are we offering to the students who are rewriting metric? So we offer lessons. We just give you a glimpse of the lessons that we are actually offering, and all these lessons are recorded. So let's say that you are unable to attend, you know, a lesson at a set at a set time, for whatever reasons. It could be that you're ill, it could be that in your area there's no coverage, it could be that there is load shedding, hence you're unable to attend. So we record the sessions and we make them available to all the students who have who have signed up with us. And then the other thing that we'll be doing is that we will be, compiling questions from different past papers from both the IEB and CAPS as well. Because IEB and CAPS, to tell you the truth, it's more or less the same thing. Those two curriculums are more or less the same. It's just that, the standard at which they ask the questions may be slightly different, but, this tutoring company, we do make sure that we cater for both students who are taking the IEB and the CAPS curriculum. We try and mix, the questions, but the questions are more or less the same. There's really nothing different. So the standard is more or less the same. And then we also offer assessments. So the questions, we bring them to class. So there will be class activities. Students will be learning from us, the tutors, and they will also be learning from their peers in class. So what we normally do is that as we facilitate these sessions, on certain days, we create breakout rooms using the Microsoft Teams meeting, depending on the number of participants that we have. But we can create breakout rooms and group the students into groups of 3 or 4, and we give them a worksheet to work on. And the expectation is that they must submit their answers so that we can take a look. Yeah, so that we can just take a look and see where there are still gaps, and we do try by all means to to fill in those gaps. So yeah, that's one thing that we do. The other thing is that we do have those assessments that we give to our students. So they are not really formal assessments. They are informal assessments, but these assessments are really important because they prepare the students for their formal assessments in their respective schools. So like, for instance, you will be writing the June exam. So before you can write a June exam, so you need to practice. You need to get a few past papers and practice. So what we do is that we set questions, we compile questions from different past papers, and we create questions as well, because we know how questions are supposed to be set based on our experiences working with the university. And we set dates and give the students assessments, and we time them, and we expect them to write the assessments within a certain period of time, and they submit, we mark and return the results to the parents. So with those assessments, we are able to gauge the understanding of the students. So the students get to learn from us, they also get to learn amongst themselves, and they also get to learn by themselves, when sitting at the homes. And the other thing is that we offer mentorship. Because we understand, we understand where most of the students come from, because from my side, I was once in your boat. I had to repeat metric at some point, hence I made it to UCT. So I do understand, the challenges that you're experiencing. And as we move along, I'm going to share the experiences that I've had as a student who was rewriting metric. So, but I will share that using another platform some other time. The experience that I have, my experiences can actually help you to overcome some of the challenges that you're experiencing, or they can also help you to overcome some of the challenges that you will experience, as you actually move on. So the other thing is that we also talk a lot about career. So career is very important. As you all know, the economic climate of South Africa is continuously changing. The rand gets weak, the rand doesn't get weak. A lot of things are just happening, a lot of things are changing. Some of the careers are becoming irrelevant in the 21st century. So that is one of the subjects that we tend to talk about during this lesson. So it's not just about teaching mathematics and physical science. Well, our primary focus is teaching mathematics and physical sciences, and maybe accounting and other subjects, but we also talk about careers, because you don't want to select a career
that will make you irrelevant in the coming 5 years. So as a student right now, you need to do research, and you need to consult us, about careers that about the career choices that or the career paths that you actually want to follow, and we will advise on whether you're going in the right direction, or on whether you should take a different direction, because you want your career to remain relevant for the next 20 years so that you can actually survive. Okay, so yes, and those, we do talk about those during the mentorship sessions, but I will talk more about the mentorship sessions as we move along. And then the other thing is that we do have a website, which is more of a learning platform. So in this learning platform, we're going to share resources. So we're going to share notes, we're going to share recordings. So these lessons that we are having, I mentioned that we record them. Normally we put them on Google Drive. But the challenge with that is that clients tend to share our recordings with other parties, So you have other third parties that are not even, part of this program, but they are getting access to our material. So this is not fair to the people who are, making payments for the services. So hence, we now have a learning platform. We're just finalizing it. So as soon as we launch it, we will make an announcement, and all the videos will go onto the learning platform. So whenever you miss a lesson, you will be able to watch the recording, but you won't be able to download it. So yeah, the learning platform, it's on the way. So it will be made available very soon. What are the expectations from us? What do we expect from you guys? One, remember, we will be giving you 4 hours of tuition for mathematics and 4 hours of tuition for physical sciences. Our expectations is that you should join this program if you are really determined to succeed. If you really, really want to succeed, if you are hungry to become very successful in the foreseeable future, then I recommend that you join this program. But if you feel like, if you feel like you won't be able to put the necessary effort that is required, I would encourage you just to wait. But if you are determined to work hard and succeed, I encourage you to join this program. As I've mentioned, this is a 4 months intense program. So we will be moving slightly fast. So we're going to pace the lessons because we need to cover the full curriculum within 3 to 4 months, since you are writing in June. And I must tell you that the exam that you will be writing in June, I think is it the supplementary exam? So the exam rewrite is slightly challenging because they have the perspective that you are actually doing this for the second time, so you know more and you understand better. So yes, so I expect you to work very hard. I expect you to attend all the lessons, unless you have a legitimate reason as to why you will not be attending. I expect you to, do consultations, but that one, it's optional. If you feel like you don't have any questions, I mean, you don't have to come through, but I do expect you to attend the consultation sessions. And I also expect you guys to put in a minimum of 14 hours of work each and every week. So if you want to get a distinction before the end of June, you need to put in a minimum of 14 hours on mathematics and a minimum of 14 hours in physical sciences. That's the only way in which you're going to ace this subject. And the other thing is that I normally advise people to, whenever we are done with the lesson, take the worksheets that we bring to class. Look at those worksheets, interrogate those worksheets, and redo them. Even though you know the answers, redo them. Why do I emphasize that you should redo them? That is because we learn and understand mathematics through repetition. When you drive a car for the first time, it becomes very difficult. you won't put in the correct gear, you are nervous and all that. It becomes very difficult. But when you do it for the second time, and when you do it for the third time, it gets easier and easier. That's the same thing with mathematics. You need to keep on repeating the same thing over and over again. I normally recommend that per worksheet, you should do it 3 times on 3 consecutive days without looking at the answers, and you will realize that every time you do it, you are learning something new. And every time you do it, you become more efficient at doing it. That's how people, that's how people get distinctions in mathematics. Me and Tafazo, we did get those distinctions in mathematics and in physics and in chemistry. So that's how we actually made it through. That's how we got to UCT, by doing these exercises repeatedly, and we committed a minimum of 14 hours. In the case of Tafazo, it was worse because he took the A-level Cambridge curriculum. So things were a little bit difficult, but he made it through. So that is just my experience. I know that people have, you have different ways of learning, different ways of studying. It does not really matter. As long as you're putting that minimum of 14 hours of work, I'm telling you, you're going to go very, very far. And then lastly, I want to talk about the payment options that we have. So usually we are lenient with payments, but experience has taught us that, if you are too lenient with the payments, then people tend to get away with it. So we've experienced challenges in the previous years. Right now, in the previous years, we used to allow our clients, to take the lessons for the full month and only make the payment at the end of the month. But, some of the clients, a lot of the clients did not honor their, the agreement that we actually had. Hence, we're going to be slightly strict when it comes to, payments, but not that strict, but we're not going to be as lenient as we used to be. So we will accept payments, or payments will be required in the first 7 days. So meaning that if you sign up to take lessons, let's say from Monday, I'm just giving you an example. So payments should be made within 7 days. So if you are unable to make payments for whatever reasons, just communicate with me, and then we can just make an alternative arrangement. So the other thing is that we do not accept any cash payment. We are based at the University of Cape Town. Most of you are actually from Gauteng and Durban and, other provinces in the country. So we accept EFT payments and cash deposit to our bank account. And the other thing is that within that 7 days, let's say that you take our lessons, but you are not happy with the service that we actually offering. So what you can do, you can actually raise that with me and Tafazo, and we will give you a refund if you're not happy with the service. Yeah, I think that's all I wanted to share with you. So yeah, that's us in a nutshell. So I'm gonna open the floor right now for questions, because I do believe that you do have questions. So if you have any questions, you can just raise your hand and I will identify you. But that's it from my side. And I thank you for listening. Any questions? Okay, maybe the last thing that I should just share before I actually so is the issue of the timetable. So this is the provisional timetable. Okay, let me just quickly share my screen. So here is the provisional, or the proposed timetable for mathematics and physical sciences. So for the students who are doing metric, so this is the timetable. So on Tuesdays, we're going to have accounting. And then on Wednesdays, we're going to have mathematics. Thursdays is physical sciences. Fridays is mathematics. So we are going to alternate between mathematics and physical sciences between Wednesdays and Saturdays. and the lessons will be running from 5 o'clock. The reason why we chose 5 o'clock is because we understand that some of you are attending, you are attending your schools. So you go to school each and every day, and you probably come back at 4 o'clock or after 13 hours. Now, or after 3 o'clock. So we just thought that, okay, maybe we should push the lessons to 5 o'clock to accommodate the students who will be attending, classes at their respective schools. And then on Saturday, we have physical sciences that will be running from 9 a.m. until 11 a.m. Immediately after physical sciences, we will be running a lesson on accounting from 11 hours until 13 hours. So yeah, I just wanted to share that. So parents, students, are there any questions? Are there any questions that you would like to ask? Please ask me questions. I do understand all 11 official languages, so you can ask me any question. Lilita? You can unmute.
Good evening.
Good evening. I think your line is breaking. Can you say that again? Hello?
Now.
Hello?
Hello.
Oh, yes, we can hear you now.
Okay, sir. No, I think on my side, I don't have any question. I am just grateful